we are going to express a function in its simplest form, which is tan inverse of cos x by 1 minus sin x, where x is in the limit pi by 2 to 3 pi by 2. Before that, let us consider the domain and range of the trigonometric functions sine and cos. As per definition, sine theta is opposite side by hypotenuse. For a right angle triangle, hypotenuse is the longest side. So, in sine theta, denominator will be the largest value, which means numerator is always less than or equal to denominator, which implies modulus value of sine theta will always be less than or equal to 1. Hence, sine value will range from minus 1 to plus 1. So, for sine function, we can give any value as input. Any real number can be given as input for sine function, but the output will vary from minus 1 to plus 1. Hence, sine function is having domain capital R or minus infinity to infinity, and the range is from minus 1 to plus 1. Similarly, in the case of cos function, we can see it by definition cos theta is adjacent side by hypotenuse. In this case also, numerator is less than or equal to the denominator. Hence, we can say that modulus value of cos will range from minus 1 to plus 1. So, the range of cos function will be from minus 1 to plus 1. Any value can be given as input for cos function. So, the domain is minus infinity to infinity. Then, we will consider tan function. Tan function is tangent function, that tan theta is equal to sin theta by cos theta. So, whenever cos function or cos theta is 0, tan function will be not defined. So, what are the values which gives cos function 0? Whenever the angle is odd multiple of pi by 2 or 90 degree, we can say that cos function is 0, cos theta is 0. In such case, we can say at those points tan function is not defined. So, for tan function or tangent function, what are the values that we can give as input? It's only the real numbers other than that of the odd multiples of pi by 2 or odd multiples of 90 degree. We have to exclude those points. Other values are acceptable. So, that is the domain for tan function. Now, the range for tan function can be anything. We can't say that by definition of tan function it is opposite side by adjacent side. Sometimes opposite side may be larger than the adjacent side, sometimes it will be less than the adjacent side. So, the value we can't restrict from minus 1 to plus 1, it can be any real number. Now, we are going to consider the inverse tangent function. Before considering inverse tangent function, we must know for to be a function to be having an inverse, like if a function f of x is having an inverse function, that function must be 1, 1 and onto. So, tangent function, to make that tangent function invertible, we must have to make it an 1, 1 onto function. To make it 1, 1 onto, we have to restrict the values of output values of input. For example, we know that the value for tangent function will be repeating within each interval of pi. If we are considering the interval minus pi by 2 to pi by 2, and then we can consider the interval from pi by 2 to 3 pi by 2, then 3 pi by 2 to 5 pi by 2, that is in the positive side, and from in the negative side we can consider minus 3 pi by 2 to minus pi by 2, minus 5 pi by 2 to minus 3 pi by 2. If we are considering these intervals, tan function will be having repeated outputs. So, we have to make this 1, 1 onto by restricting the domain. If we are restricting the domain to any part of these intervals, like if we are restricting to minus pi by 2 to pi by 2 or pi by 2 to 3 pi by 2, or any interval that I have specified now, we can get inverse function, because the tan function at that time it will be invertible. It becomes 1, 1 onto. As a result of that, it becomes invertible. So, at that point only we can define the tan inverse function. That's why in our problem the x value is given the range pi by 2 to 3 pi by 2. and then only we can define this tan inverse function.